Hello all. Today we are solving LeetCode problem number 3546 equal sum grid partition part 1. So you are given a m cross n matrix named grid of positive integers. So your task is to determine if it is possible to make either one horizontal or one vertical cut on the grid such that each of two resulting sections formed the cut is non-empty formed by the cut is non-empty and the sum of elements in both sections are equal. So the ask of the question is possibility to check if any vertical or any horizontal cut could be possible in such a way that sum above the cut is equal to sum below, or sum left is equal to sum right. So this is what you have to check. So if any one of this case or this case is true, you will return true. So how do we do that? So it is very straightforward for this problem. We will be able to solve this problem with time complexity of big O of n square. So it's very straightforward approach. So first thought when I am thinking about this problem is calculate the total sum, and when we are partitioning this, we partition the complete row or the complete column, right? So when we are partitioning it, we will have some n rows. Now totally we have n rows, so this will be some k rows and the remaining will be n minus k row, right? So you calculate sum of this and sum of this, and eventually this sum, which is the k sum, the total minus k, if it is equal to the k part actually. So what exactly it means, if it is able to cut it into half, you will get uh, a, the total half of the total value when dividing any such rows, right? So this is what we have to check. So if this is true, then in that case you can return true. You will continuously you repeat this unless you get this condition satisfied, else you will move to the column. So similarly you will calculate any portion which is called as k, and if total minus k is equal to the k, again you can return true. So let me run through the example one. It is very tiny example, and then we can have you can confirm the observation and jump into the coding part. So here we have 1 4 2 3, and starting with row 0 you have 1 and 4, and before that I've completely forgot the total sum is 1 and 4, which is 5 and 7 10. So total sum is 10. So now what's the row 0? When you calculate the current sum is equal to 1 plus 4, which is equal to 5. So now the k is 5, or the current is equal to 5. So total minus current should be equal to current. So 10 minus 5 is equal to 5. So 5 is equal to 5. So this is true, so we can directly return true. So if you want to check further, we can check, or if you want to check the column part, it is fine, but column part is anyways not satisfied because this is 3 and this is 7, so it is not equally the sum is distributed equally. So in that case it is true for the row part, and one true is enough. One part where the condition satisfied is enough, and we can straight away return that as an answer. So we solve this with the time complexity of big O of n square, because we will be calculating the sum using big O of n square, and the row sum and condition satisfying again will consume big O of n square, and similarly a column also consumes big O of n square. So you have big O of 3n square as time complexity, which is big O of n square, and there you go. With this observation, let us go ahead and code this up. So let's start with n, which is equal to length of grid, and m is length of grid of 0. So now for calculating the total sum, we will have total, which is 0, and then iterate through the grid and then calculate the total. So for I in range till n times, for j in range till m times. Now total plus or equal to grid of I j. So now total part is done. So now we have to process the row and process the column. So in terms of row, we will have the current variable, which is 0, and again we have to iterate, then we have to subtract from the total and compare if it is equal to the current, right? So for I in range n times, and for j in range m times. So now we have to check if total subtracted by current is equal to current. If it is true, then return true. So now similarly we have to do the same for column. So column comparison is also 0, but for column based processing we have to change the looping, which is for j in range m times, and for I in range n times. So now I think I forgot the main thing, because to calculate the current, here we have to increment current is plus or equal to grid of ij, because we are adding the complete row, right? So this is grid, and now here this will be again ij, so plus or equal to grid of ij. So if total minus current is equal to current, so now in this case again we will return true. So yes, I think that is it. If nothing works, return false. So let us run it. This should be current. Yes, let me submit it, and there you go. Thank you.